Good morning, this is part 3 of the DIY motorized camera slider project. In part 2, which should appear right here, we have gotten the mechanism working and the camera moving. Now, we are going to add this Arduino controller board, which is going to allow us to make some moving time lapses, which is one of the only reason that you own a camera slider. So today it will be my first real Arduino project. Let's get started! So I upload the code on the Arduino board. I will explain in detail the code in next week's video where I'll be focusing on the code, and you can simply copy and paste the code, which should be down under in the description, or otherwise I will put a comment under the video with the code, which you can also copy and paste. Next, I remove the old wiring from part 2, and I cut some connector wires for the Arduino board and start making the wiring. This is quite a long and tedious process, and I highly suggest getting quite a bit of solder. A great tip is to use sticky tack in order for your components not to move around when you're soldering them. Well, I have what you would call a delay. It is pouring rain outside and there is a huge thunderstorm, and I do not have any solder left. Thus, I will have to wait before going to the store. So, I have gotten some new solder, but still, the yellow solder never works. Never buy the yellow solder. It is shitty. But anyways, I have managed to finish my wiring. And it is time for a test. For the project to work, you will need two power supplies. One for the motor and another one for the Arduino board, which can be very easily bypassed by using a multi-plug head adapter. I suggest writing down the pin numbers when you are doing the wiring of the Arduino. But once I try it out, the motor does not move. I don't think that the problems come from the code, because the LED and user interface is working. But I have found that the small transistor tends to heat up a lot, up to 150 degrees. That is because too much current is flowing through the transistor. Well, anyways, to go around that issue, I have used what is called a power transistor, or also known as a resistor, which can allow much higher amounts of current to flow through. And of course follow the datasheet when you're soldering it. Then it was not working, and the motor never moved, not even once. And that is because I had two different ground terminals. So I was trying to find a way around that, but after a quick look on the internet, I have found that you can simply power your Arduino board with 12 volts. So this problem is fixed. So I soldered the new cable so that I can power the Arduino with the 12 volt power supply. I changed my ground connections, and now the motor is spinning, but not as it should, and some voltage is always moving. I can see some changes in the speed of the motor when there is the pulse, but it still is not working. I have also tried tweaking the code, but no great results. So when there is a 0 volt potential on the motor pin, then the motor is not moving, but somehow there always is a 5 volt potential or 3.3 volt potential on the motor pin when there is a connection with the transistor. I do not really understand why. I have also tried switching the collector and emitter connections of my transistors, but with no results. So in my despair, I have tried soldering in a new transistors which I have scavenged from an old PCB, and now the circuit seems to be working and the motor is spinning properly. I think that my previous transistor had weird mechanics inside, such as two different transistors at the same time, and thus tweaking a bit the pins and its uses. I have added a longer length of cable to my power supply because there is not always a plug near the place where you want to get your shots. It would be better to use some batteries, but I do not have the components and they are rather expensive. And for me, since it is rather bulky, I am not going to bring it outdoors too much. Also, don't forget to add some heat shrink because it is way nicer than electrical tape. Check the polarity of the voltage and annotate it with a piece of tape. And we can get some pretty decent time lapses. But now, when we want to program and start our time lapses, we have to deal with a mess of cables. Thus, I am going to make a nice wooden case for the Arduino and all the buttons and LEDs. So I start by drawing some rectangles on pieces of scrap wood and then cutting them with the help of a saw. So that is it, and then I hot glue my layers because our case does not have to be that much strong. And in the end, this gives us some space for us to place our Arduino and our wires. Also, don't forget to leave a small hole to place your wires which come to power the Arduino and the motor. In my case, I needed to unsolder this wire in order to make it fit in the hole and then resolder it again once it was inside. Also, don't forget to thin the edges so that you can get a much nicer box and look. I have drawn the main user board where there will be the push buttons and the LEDs, and I have marked the holes which I then drill. But unfortunately, I split the wood. And then I hot glue my LEDs and switches inside the main user board, and it is time to rewire the Arduino. And yes, I admit it is a cable mess. Thus, once you manage to make everything fit inside, you can hot glue on the upper user cap, and the project seems to be complete. So anyways, I think that it is a very cool filmmaking tool. I am not going to use it that often, but I have learned a lot about coding. Well, here is the final pins that you want to use for your Arduino, and the code will be pasted into the description and in a comment. Thus, you can just copy and paste it in your own project. I did not mention the code too much in this video because I will have another separate video where I go and explain the code line by line for the people who would like to understand how this code works. In conclusion, I think that it is very cool, and here are some decent time lapses that I have taken with it.